Hello everyone, welcome to our case study on Juice Perfect's manufacturing strategy and operations. The presentation for the title is Analyzing Pain Points and Proposing Improvement Strategies. Let's have a look at the executive summary overview. The current situation requires optimized raw material acquisition from the vendors and efficient asset management. There are two challenges associated with the current situation. Firstly, the company is suffering from several inventory issues, and secondly, ineffective management of technical personnel and spare parts. To address these challenges, two solutions are presented. Warehouse management can be improved using a blend of mathematical and technological approach. Unplanned downtime can be reduced with an improved replenishment and team management plan. The initial approach is to find the worst performing plant on which we can implement our recommendations as a part of the pilot plan. We have been provided internal performance metrics in the case as total annual runtime, total unplanned downtime, and mean time before failure. When you compare the ratio of total annual runtime over total unplanned downtime, it gives us the highest value for Florida manufacturing plant. Also, mean time before failure value for Florida plant is the lowest, which makes it the worst performing plant. To uncover the pain points, we conducted a Pareto analysis on the provided dataset and found out the major reasons for raw materials and assets mismanagement, which are outlined below. The ways to resolve these issues are discussed ahead. Around 31% of the raw material management issues are coming from the misplacement of items in the warehouse. To address this issue, we are proposing two approaches. The first one is zoning, which is segmentation of different raw materials in the warehouse based on product features will be conducted on improved location. The second one is blockchain technology with Internet of Things. Although moderately expensive, it improves tracking through overall supply chain, ensuring transparency and improves the flow of information in the organization as well.
Based on operations flowchart, raw materials are coming both from vendors and from truck yard, which are being staged for production and filling or packaging at the same time. We have proposed an equation which can be used for refilling. In the equation, Qij truck is for quantity of product type I with subcategory J in truck at time T. Qij T prime is quantity at time T prime. Qijt is quantity at time T, Rfj is filling rate for subcategory J, Rpij is production rate for product I with subcategory J, Zij T prime minus T is decision factor whether truck will unload or not, which is decided by the binary variable of 1 or 0, and here T prime is greater than T. The layout shares inventory for production as well as filling or packaging materials without any predefined ratios. We propose a zero inventory policy for finished goods as they will occupy additional space and devise a KPI in the form of a ratio of storage space of raw materials upon storage space of finished goods. The aim is to maintain the ratio with bounds to facilitate smooth production and avoid any shortages for raw materials. The main cause for unplanned downtime is lack of expertise in some technicians, which is resulting in task completion sometimes before planned time and sometimes after it. Initially, technicians can be scored based on expertise and then organized in groups with members having different scores. This will result in better coordination between team members and increase their efficiency over time. Finally, we propose a reserve team which will step in cases of emergency and critical maintenance. Spare parts shortage can be tackled in two ways. First way is the replenishment model, which involves different variables and historical records to analyze trends and make better predictions. Second way is to improve forecast or planning issue at the base level of planner, leading to ripple effects of reduction of back orders on maintenance days and better planning for spare parts for next maintenance day.
To summarize our results, blockchain technology with Internet of Things will improve the overall supply chain management. The inventory management can be improved by improving the flow of materials between the warehouse and the truck yard. The shortage of spare parts can be minimized with increased accuracy in planning and forecasting. And finally, a technician's performance gap and stability could be significantly improved by forming teams based on analytical approach. To conclude our presentation, we can implement the recommendations in the pilot program on the worst performing plant in Florida. In future, based on the outcomes from the pilot program, we can implement the program on the other plants as well. And finally, a full-fledged mathematical model along with warehouse dimensions would make the approach more feasible and would allow us to implement the recommendations in a more meaningful way. Thank you for watching our presentation.